Hello, today's video we're going to be talking about section 9.6, wind and water current. Let's start just by talking about rate. Imagine if you're swimming or in a rowboat and your speed, let's talk about the rowboat situation. The speed at which you paddle your rowboat, we could call your rate. So R equals speed of rowboat paddling. Let's say you're in a river though, and in that case there's a water current. So we could say C equals the speed of the water current. So then going downstream, your rate would actually be your paddling rate plus the rate of the water, or the rate of the current. So downstream, you get your own speed of rowing plus the speed of the water. Now upstream, it has the opposite effect. You get the rate at which you paddle minus the rate of the current, okay, which we're calling C. And you guys have probably felt this before, either swimming against the current or rowing against the current. Look at page 440. We'll start out just with the rate situation. So it says, in problem number 1, the rate of the rowboat going downstream is 15 kilometers an hour. This problem specifically talks about rate only. So we're not dealing with distance or time or anything else. So the rate of the rowboat going downstream is 15 kilometers an hour. The instructions of this part say let R equal the rate of the rowboat, which we have up here, and the C equals the rate of the current, which we have right here. So the rate of the rowboat going downstream, meaning the current is helping it, is 15 kilometers an hour. So we can say the rate of the boat plus the rate of the current equals 15. So that would be an equation for the rate of the rowboat going downstream. In number 2, it's a similar situation, except the rowboat is now going upstream. So we have the rate of the rowboat minus the rate of the current equals 10. So those would be the answers for 1 and 2. Now for number 3 and 4, I'm just going to do one of these. So I'll do 4. Hint, that means you'll be doing 3 at some point. The rowboat takes 2 hours to go 20 kilometers upstream. So now we're talking about more than just rate. We're talking about time, and we're talking about distance. So now we have to remember, I'm going to move this down a little bit, from earlier in the year, and maybe from even before this year, we have a formula, distance equals rate times time. And so if we want to write an equation that expresses number 4, we're going to want to use that formula. So the distance is given as 20 kilometers. We can just write 20. And the rate is not given. So we don't know the rate. And we know that the time is 2 hours. So R times 2. So we know 20 equals R times 2. But there's one more piece of info that we have to use, and that's upstream. Okay, so we have upstream. Remember, the rate isn't just going to be R. Now it's the combination of 2 things here. And so our upstream was right there. So let's rewrite number 4. So we're going to do 20 equals upstream. So we have R minus C times 2. So 20 equals R minus C times 2. and that's how we can show the equation for number 4. If you look at number 5 in the book, it talks specifically about the rate only. It says Jim's motorboat travels downstream at the rate of 15 kilometers an hour. Going upstream, it travels at 7 kilometers an hour. Write an equation that expresses each fact. Remember, a rate is a distance over time. So all of these units here tells us rate. There's no talk of distance and there's no talk of time. So 15 kilometers an hour is a rate and 7 kilometers an hour is a rate. And it says write an equation that expresses each fact. So we don't have to worry about distance and time. So downstream at a rate of 15, so that is R plus C, because he's going his own rate plus the current downstream equals 15. And then upstream, he travels at 7 kilometers an hour, that's upstream, so R minus C equals 7. And that section just talks about writing two equations. Now let's start with problem 11. So problem 11, it reads, a plane travels 8,400 kilometers against the wind in 7 hours. With the wind, the plane makes the return trip in 6 hours. Find the speed of the plane in still air and the speed of the wind. Okay, now this is not a rowboat problem, it's an airplane problem, but the physics is the same. So the wind is acting just like the water current would. So if the wind is behind you and you're going with the wind, it's going to push the plane. And if you're flying into the wind or against the wind, it's going to push the plane backwards in a sense, right? Relatively. It'll slow it down. So we're going to make our rate time distance chart. Rate times time equals distance. Okay, and the two things we're talking about are a plane going with the wind, and then against wind. Okay, it says that the plane travels 8,400 kilometers against the wind in 7 hours. So we have 7 hours. We have 8,400 kilometers. That's 8,400. And it's with the wind. Well, we don't know the speed of the plane, and we don't know the speed of the wind. So again, the speed of the plane, we're going to say R. And the speed of the wind, instead of C for current, we're going to just say W for wind. Now against the wind, the rate is going to be the opposite. It's the rate of the plane minus the rate of the wind. So it might help to say something like R equals speed or rate of plane, and W equals speed of the wind. All right. And so against the wind, it says the plane makes the return trip in 6 hours. And it doesn't tell us the distance, but since it's a return trip, we know that it's the same. Okay. Now, a lot of you, when you set up your equations, now we have two equations. Equation 1, it's just the top row. The rate, it's rate times distance, but time times rate rate times time, but I can flip it to say time times rate because I want that 7 up front. So we have 7 times R plus W equals 8,400. And then we also have, for equation 2, 6 times R minus W equals 8,400 as well. So a lot of you guys will be tempted to distribute the 7 and the 6. If you don't do that, it turns into a really easy elimination problem. So for equation 1, instead of multiplying the 7 through to the R and the W, let's divide everything by 7. giving you R plus W equals whatever 8,400 divided by 7 is, and I think it's going to be 1,200. Let's see, 7 times 10 is 70. 70, yeah, 12, 70, 77, 84. Good. And then equation 2, instead of distributing the 6, we're going to divide both sides by 6, and we get R minus W equals whatever that is. So 60 and 24. So I'm thinking 1,400. Let's make sure that's correct. So 14, 28, 42. Yeah. All right. So now equation 1 and 2 look like this, which is an obvious point for elimination. We can either add or subtract because the coefficients are the same either way. I find addition to be a little easier, especially when dealing with opposite signs and things. So R plus R is 2R, W plus negative W is 0, and then 1,200 plus 1,400 is 2,600. Dividing both sides by 2, we get R equals 1,300. Plugging back into, now we could go all the way to the beginning and plug into the 7 times the R plus W and all that. But look how much simpler it is if we plug in right here or here. That makes it really nice and easy. So I'm going to plug into equation 1 and 1,300 plus, that doesn't make any sense, does it? 1,300 plus a wind of negative 100? No. All right. So I think I made a mistake here. Let's double check. 2R26. Okay, so I'm going to go back all the way to the beginning, which is what you can do when you think you've made a mistake. The plane travels 8,400 against the wind in 7 hours. Aha. Problem way in the beginning. So, against the wind was 7, and with the wind was 6, which makes a lot more sense. So maybe if you were following along, you realize my mistake right away. So that would only change a couple things down here. So let's fix that up. Notice I'm not erasing everything. I'm just erasing the parts that I need to change. So this is the 7, and this is the 6, and that would change these two, so 1,400 and 1,200. So the 6, so 1,400, 1,200, 26, 2R equals 13. Okay, that makes more sense now. Now, I didn't stop the video and erase it and make a new video on purpose because I really wanted to show you, that was a legitimate mistake, I messed up, but I wanted to show you how I went about figuring out my mistake, how I go back, check the words, and change what is necessary. Notice it did not take very long once I figured out the mistake. So now I know that W equals 100. So I think that the rate of the wind is 100 and the rate of the plane is 1,300. Let's see if that makes sense. So going back to the words of the problem, if the plane travels against the wind in 7 hours, that would mean it would be going 1,200 miles an hour for 7 hours. That's 8,400. That works. And then with the wind, it'll take 6 hours, so 1,400 miles an hour, or kilometers an hour actually, times 6. So 14 times 6 is 14, 28, 42 times 2, 84. So 8,400. So these are the correct answers, and we made it, even though we made a mistake.